In this example, we know that 35% of households in La Crosse have a dog. So I'm going to start by just labeling D for dog. And we know that the probability of a dog is 0.35. We know that 28% have a cat. So let's let C stand for cat. Probability of C is 0.28. And 52% have a dog or a cat. So that tells us that the probability of D or C is 0.52. Then we want to know what's the probability that a La Crosse household selected at random has a dog and a cat. So we want the probability of D and C. So by writing out what we know and writing down what we want, we can try to piece together if there's any formulas that allow us to accomplish that. We do have this formula that says the probability of one thing or another, so here D or C, is the probability of the two things being added together minus any overlap or the and statement. So we did a problem earlier where we sort of did this directly and had everything on the right-hand side and we got the left-hand number. Here we can still use this formula. It's just used in a little bit different way. We happen to have this left-hand side number this time, the 0.52. We also have this 0.35 and we have this as 0.28. And this is actually the piece that we're looking for. So in this formula, there are 4 probabilities. If you know any 3 of them, you can solve for the missing one. So what we get here is 0.52 equal to, if we add these two together, we'll get 0.63 minus the probability of D and C. And so for this equation to hold true, if you do some algebra on it, you'll find that the probability of D and C is 11% or 0.11.